my intro into pottery was really through the science of it, and I am a total glaze nerd. I love everything about glazes. I love everything about glaze chemistry. What I'm going to just do a quick demo today is a triaxial blend, and typically when someone does a demonstration doing a triaxial blend, we think about everything in 100%. But I'm not going to do it that way because I'm going to conserve materials. You don't always end up with colors that you really like, and you can end up wasting a lot of materials that way, so I want to be a little more eco-friendly. And when Ginger asked me to do a demo, I was like, I want to do something with rainbows to honor Pride Month because it's Pride Month this month. So I brought some examples. The first one, this is a line blend between two glazes. So you start with a red glaze and a yellow glaze, and you change 10% of the constituents of each glaze from yellow going to red. So you would start 100% here, 90, 80, 70, 60, and so on. And you do the reverse with the red. So it's 100, 90, 80, 70, 60, and so on. And so with two glazes, you can end up with a multitude of colors just by, and these are commercial glazes. These glazes here, and so I did tried to do the primary colors with these, so red, yellow, and blue. So this is the same red, it's just on a different clay. This is on standard 112. This is on, I think, 365 porcelain, all cone 6. But these and these are all stain-based glazes, so they're going to be a base clear that has some kind of a stain that's been added to it rather than an oxide color. Clayscape's butter, and this is on a really dark clay, and this is on 112, and then the same for spruce blue on 112 and then on the dark clay. But the combinations between them, I really liked some of these greens that I came up with. So I thought I'd do the same thing and try to add a primary color that's going to be Clayscape's cranberry. And I don't know what's going to happen. We're going to end up with who knows what's going to happen in the glaze chemistry. And this is typically what you get when you go to do a triaxial blend. Everything starts with each corner being 100%, and you end up needing 2,200 parts of whatever you're going to use. So you're going to start out with 100% in the corners. You're going to need, if you're using milliliters as your parts, you're going to need 2,200 parts, which is almost 5 pints of wet glaze if you were going to do this full line blend. So then my next sheet, when I teach this, I give an example for everybody to fill out because I'll explain kind of how you work the graph here. This method I was taught actually in my geology classes before I even learned how it applies to glazes, because in geology, every crystal has a different crystalline structure, and the mineralogy that makes up the crystals, you have different percentages of things, and we do it with line blends, we do it with triaxial blends, we do it with quadraxial blends and pentaxial blends. So in my handout, I also have the math for the quadraxial blend method, and then kind of a scaled down quadraxial blend method. And if it was in color, you would see this is a pentaxial, beautiful rainbow of colors, but our color printer wasn't working this morning. So what I'm going to do is, rather than doing these 100%, so when you do it by 10%, it's 2,200 parts of material you need for each A, B, and C constituent. When you do it with every 20%, you only need 700 parts of each item, which is still almost 2 pints of glaze if you were using wet glaze. So I just dropped a 0, and that's my trick to make it smaller. Is instead of 100%, we start with 10. Instead of 80%, we do 8. Instead of 60%, we do 6. So let me get to what we're going to do here. So on a triaxial blend, you have an axis that's dominating in your, whatever your A is. And your A could be anything. It doesn't have to be glaze. It doesn't have to be mineralogy. It could be blends of tequila. It could be blends of chocolate. It could be blends of salsa. And you're trying to figure out which one tastes the best. So this applies to many different things if you want to do it that way. So on this axis, the A, where I've colored blue, A is our dominant going this way. So A starts this way, or excuse me, A starts this way. So A is on the point here. So we go down A10, A8, A6, A4, A2, and then no A, because A is out of the mix. So then we start, this axis is B. So we start B10, B8, B6, B4, B2. And then the C axis is just C10, C8, C6, C4, C2. So by blending those things together, we're going to end up with 3 line blends and all of their combinational blends. And the way that I do that is I'm going to use 3 colors. So I'm going to use cranberry. And the same thing applies when you do it for quadraxial blends. You start out with, well, on the main quadraxial blend, you designate an axis as being the dominant for that color. So if A is this axis, B is this axis, C is this axis, D is this axis. So when you come into your first cell and you try to do a mix of 4 different things, you say, okay, what's A here, what's B here, what's C here, and what's D there? And you fill everything out. So the other trick that I use in my studio, normally when I'm doing larger glaze blends, I'll use 100 milliliter syringe because it automatically does the math for me. It's 100% when I pull it to 100. It's 80 when I do 80 and so on. So I don't even have to really think at all. In this case, I got 10 milliliter syringes. And these are 14 gauge needles, which your traditional 60 mesh glaze will fit through a 14 gauge needle, hopefully without too much clogging. But I get, I like them pretty because I like everything pretty in the studio. I get these like little head pins with pretty little flowers on the ends, and that's what I use to clean out all my nozzles because I do a lot of stuff with drawing, with needles and nozzles and lab equipment. Grab these so that I know we're doing butter on that corner, doing spruce blue on this corner, we're doing cranberry on this corner. When I worked in the studio, so I worked at a water quality lab, but I also worked in the studio part-time. So cranberry, we're going to start, A is cranberry. So all we need to do is know 10, 8, 6, 4, 2. So I'm going to start with 10. And I always go past 10 milliliters to get the air out. Let's pop the air out there. I got air bubble trapped. Go slower. So I try to make sure that the line, just like in the lab, is lined up well. And then we're just going to take the 10 and put it right into that cup. And we're going to go to the 8. This gets a little bit boring if somebody wants to play it too. They're welcome to. And an interesting thing here is these 2 glazes, wet, look very similar to each other.
Confusing them.
That's why I put them in their corners.
That one's still an 8.
That's still an 8. So we're going A, 8. On the A axis, it starts in the corner, so we go 8, 6, 4. And I'm going 20% right now, rather than 10%. It conserves glaze, and often you see a change more at 20% than you do at 10%. 6. I heard some air. I lifted the nozzle out. I don't glaze too far. I like this method too because I don't get really messy.
Yeah. We hate to get dirty. Yeah.
At least with glaze, I try to keep it a little cleaner. I don't mind with clay, I get really messy. So now we're going to go to the 4 for the next line, so we're right here. Hopefully I'll get these fired this week too, so we can get them into the picture. It's a good way to do a test, but when you start to scale up your glazes into larger amounts, you might not get the same effect unless you're using really fine, like lab grade weight equipment. And if your hydration of your glazes changes, then how much oxide you're putting in each cup changes too. The other thing that I like about doing it little bits like this is I can do all my food safety testing on little tiny bits. The chemistry can change so dramatically in the kiln that two glazes that are food safe mixed together or overlapped in the kiln may no longer be safe. We'll do 10, so butter's here, so we'll do 10, 8, 6, 4, 2. Going. So we've done A, we've done B, now we switch over to C.
Where do you get these cups?
The dollar store, the $1.25 store.
Costco, Sam's.
To clean out my little syringes, I always keep water handy, and I actually
I have a question about the whatever.
the Triaxial Blend.
Yes,
Yes.
Triaxial Blend, okay. So red, yellow, and blue, isn't the middle just gonna be brown?
No,
Oh.
it's not. It's going to be, well, so in the case of these stain-based glazes, yellow tends to be much stronger than the other colors. So you can see like yellow, like automatically it's going further down this line than the red is. So that it depends on the glaze, and it depends on what's in it, and it depends on the chemistry, it depends on the fluxes, and everything that happens when it becomes magma in the kiln, basically. But like for this particular case, I don't know what we're gonna end up with. I've never done this particular test before, so I would love to see that this goes like red, orange, yellow, but I don't think that's gonna happen.
Why did you choose these particulars?
Partially because I know how they act in the kiln. They're commercial glazes. I don't have any visibility to the recipes in these glazes, so it's just from a little bit of experience of knowing that they might be made up of the same base glaze. I know that all of these are the same base glaze, so like I know that as a fact from Clayscapes. So this is like a lot less risky to go and do a blend like that. But these, I don't know. I just know, like, I picked these two originally because they're semi-mattes. And they react kind of similarly. They feel similar to each other when they come out of the kiln. And I like them. So I wanted to see what they did together. And they don't do the same thing when you layer them as they do when you mix the glazes together, too. I should mention that.
Layer or mix them?
So, like, if you were to dip butter and then dip this over it, it's gonna, the overlap is not gonna be the same as if you mix all the stuff together. Your questions?
That is really neat. Awesome.
Well, I can't wait to see it.
Me too. I love the Glaze nerdom. This is 10 milliliters per little cup. I'll mix it up really good with a brush too before I put it on clay, just in case there's any parts that are wanting to stay unmixed.
So you
Very much.
Oh,
yes,
thank you.
We appreciate it very much.
I just love unexpected results. Thanks so much for watching. You can catch more of my videos on my YouTube channel at Amy Lee Pottery, and you can sign up for my newsletter at amyleepottery.com. Have a great day.